All right, so we are at the top of page 21, right? 5.6. So after 5.6, have a quiz, and we have 5.7, 5.8, review, and then test. So the test for D period is the 29th. So it's like a week and a half-ish. You know, it's a Wednesday. Cool. We'll discuss when extra time and blah, blah, blah when we're a little closer to the actual exam. So 5.6 is the remainder and factor theorems. We didn't finish the last page of this, right? Did we finish this lesson? The last one we did this, right? End behavior? We'll just start with this little bit of a warm-up because I know we were a little rushed at the end and I want to make sure you guys understand this. So example 3 of the previous page, just because D period didn't get to it. What? Okay. Oh, not the previous page. Yeah, 17. Okay, so we're looking at end behavior. Page 17. And say the function graph below, is it even or odd? So as a little warm up, we're going to graph with our hands. What does x squared look like? Ready? Let's try this again. What does the absolute value of x look like? V. Y equals x. It's a line. Yeah, how about x squared? Parabola. Okay, how about x cubed? Do we know what that looks like? Something like this, right? Okay, so if I have an even exponent, what happens to your hands? Even exponent, they are facing the same direction. And if you're odd, you're facing the opposite direction. So is this even or odd? Odd, because they're facing opposite directions. Wonderful. See, you guys got this. It is odd because the ends are going in opposite directions. All right, B is asking for the degree. So maybe this is x squared plus 2x plus 1 or something, right? I'm sorry. Cubed plus x squared plus x plus 1, right? I don't know if this is the actual equation of the graph, but when I ask you this question, I will give you the actual equation, right? Does that make sense? Like, I'm not going to ask you what the degree is without actually giving you the polynomial. So what is the degree of this graph? 3. Who answered that first? Let's see. Elizabeth, how do you know? Yeah, it's in standard form, right? Biggest exponent to smallest, and the degree is just the biggest exponent. Wonderful. Okay, how many real zeros are there? So real zeros mean not imaginary. Okay, so real zeros mean x-intercepts. We're looking where we cross. There's one. There's only one, and I'm highlighting it right there. There's only one of them. Okay, and then we got to estimate the real zero. So what's the actual coordinate, right? So look, what does this look like it is? Okay, so -1, -2. Okay, so -2.3, and then the y value is 0. See, perfect. You guys know this already. We're golden. Now we have to describe the end behavior. Things I really care about you knowing. If it's even or odd, what is the degree, right? Like, so you look at the polynomial. How many real zeros? So knowing you cross, like how many times you cross the x-axis. I might have you estimate. I don't know. I just okay, if you understand that is one of the zeros, cool. And then the end behavior. So you can write as x goes to positive infinity, what is happening to f of x? And then we say as x is approaching negative infinity, what is happening to f of x? So remember, f of x is y, right? F of x is another way to say y. Okay, so this first one, right? As x goes to positive infinity. Positive is to the right. Okay, so as I go to the right with my x, what is happening to y?
It's going that way too.
It's going up as well. So that's why we say it's going to positive infinity, right? Because as I trace my x's that are bigger and bigger, I see my y is going up. Okay. Now, as x goes to negative infinity is to the left. So as your eyes look at the graph, and as they go left, the y value is going down. Do you see how it's going down? Do you see the arrow going down? Yeah, so it's going down. So we say it's going to negative infinity. And that's it. This is the end behavior. Does that make a little more sense now, hopefully? Okay. So, perfect. We'll knock out the 5-6 lesson, go over some 5-3 practice.
Is that like all for this chapter?
No, we have 5-7 and 5-8 after this.
Well, I mean, like, it's not the chapter, like, the region.
For the lesson?
Yeah, the lesson.
That was it for 5-3. Yeah. That was it. I mean, all that right here, it's just more review. What I just like skipped over, right? All these other pages, just more review. This is your homework. Actually, is this what's on the study guide? Are these the numbers that are on the study guide? Okay, cool. I want to make sure I copied them correctly. It should, okay, so I looked at it and I felt that it should go relatively quickly because some of them are like, what's the leading coefficient? What's the degree? Okay, that takes you 5 seconds, right? Okay, 5-6. Remainder and factor theorems. So, synthetic substitution. So we learned synthetic division already. Okay, we've used long division and we know what direct substitution is. So there's a quicker way of finding an answer than direct substitution. Because if I have a polynomial that's really long, like x to 11 plus 9x to the 10, blah, 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 right? Like 11 terms. Oh my gosh. It's so easy to mess up and like x, whatever with your exponents in your calculator. So there's a quick way to find the value of a function. Okay, so let's find it 3 different ways and let's see what the value actually would be. So synthetic division can be used to find the value of a function. Do you know what the value of the function will be when you use synthetic division? It will be whatever is the remainder. Yeah, pretty cool. Okay, that's what you're going to learn. So first, let's do direct substitution. Hopefully this will be review from, chapter 1. Or yesterday, we did a couple problems like that. So I'm plugging 3. Oh my gosh, my parentheses are horrible. You got to plug 3 in. Everywhere where you see an x, you're plugging 3 in place. So I have 3 times 3 cubed minus 6 times 3 squared plus 3 minus 11. So I'll give you a moment. So we're just plugging in and finding the numbers. So we find the answer is 19, right? Direct substitution. This is not too bad because it's only a cube function. Yeah. So I told you when you divide, we will get, the remainder will be the value of the function, aka it'll be the y value. When you divide, the remainder will be the y value for the x we're interested in. Okay, so this next one, if I'm wanting to find f of 3, right? F of 3 means when x equals 3, what is y, right? F of 3, we're finding the y value when x equals 3. So I said x equals 3. So I'd like to put this in terms of like a factor. Remember chapter 4? Like I gave you 2 roots and you had to write a quadratic from them. Right? If I said, I have 2 roots, how do I write them as a factor? So I'm going to subtract 3 on both sides. And so I'll make the factor x minus 3. If I'm trying to find the value at 3, what I'm doing is I'm saying, okay, let me revise. Okay. So imagine that the function value in direct substitution in part A was 0. Imagine the answer we got was 0. Right, I plug 3 in and I get 0. What does that mean? That means 3 would have to be a solution, an x-intercept. Yeah, because if the y value is 0, that means that the x will have an x-intercept. So if it's 0 there, that means it has to be one of like the factors. How do we find the x-intercepts? We set each factor equal to 0. So if x equals 3 was an intercept, that means x minus 3 would have to be a factor, right? Because you always set your factors equal to 0 and then solve. So when I'm dividing by x minus 3 on long division, I'm testing, is it a factor? If it's not a perfect factor, if it's not an x-intercept, I'll get a remainder. And the remainder will be whatever the y value is. So for b, what should the remainder be? 19. We should get a remainder of 19 because that is the y value when x equals 3. So I'm explaining why we're dividing by x minus 3. So, little bit of review, long division. Let's try this out. So first I take 3x cubed, divide by x, and I get 3x squared. Alright, I have to distribute. So I have 3x cubed minus 9x squared. Draw the line and change the sign. So negative 6 plus 9 is 3x squared. Bring down the plus x. Have to do division again. So 3x squared divided by x is going to be 3x. Distribute it out. Draw the line, change the sign. I'll pause here to make sure we're all caught up. See if you can finish this out now that we've done 2 rounds together. Okay, so those are the 4 rules, right? Blah, blah, blah. Those 4 are for long division. I'll do the last one now. So 10x divided by x is just 10. Distribute, so I have 10x minus 30. Draw the line, change the sign. I get 19 as my remainder. So I want you to notice, this is the same thing as what we found before. This is f of 3. All right, your remainder. So if we know when we divide, that's our remainder. Cool, we just do synthetic because it's always much, much faster than long division. Okay. I got 3x cubed. But do you see the stuff in red? You have to have 2 terms per line. Do you have 2 terms per line? Oh. Do you have what I have then? Oh, okay. No problem then. Alright, so if I'm taking 3x cubed minus 6x squared plus x minus 11, right? And dividing by x minus 3, I could do that whole thing with synthetic, and it'll be much, much faster. You ready to try synthetic? Okay, you ready? Give it a try. I don't know, I'll give you like 15 seconds or so, right? A little review. Synthetic. Try it out. First one, bring down. Then you must multiply. Then add inside, multiply outside. Add inside, multiply outside.
Are we supposed to get the remainder?
Yep, we get a remainder of 19. Are we surprised? No, because that's the actual function value, right? Not surprised. Shouldn't be surprised. It's the same number as what we found before, because this is how we find the value of my y when I have my x. This is called synthetic substitution. The first thing we did was direct. You plug your number directly into the polynomial, but this is synthetic substitution to synthetic division, and you just write your remainder as the answer. So secretly, it's not different. All you're doing is doing synthetic division, but instead of writing the whole thing out, you just have the remainder, and that's the value. Yeah. Not really new, it's just a different way of looking at it. Yeah. So if I'm asking for you to divide a polynomial by another, okay, you have to write the whole thing out. But if I'm asking you to do synthetic substitution, if the directions say synthetic substitution, you do synthetic division and you write the remainder. So, ready for this? This is the answer. If I asked you for synthetic substitution, this is what you write. That's what you write. You don't write the whole thing, right? Not the whole polynomial, just the remainder, because that's the y value. So, notice that the same value, f of 3, is obtained by all three methods. Whatever the graph of this function may look like when x equals 3, f of x equals 9, right? So f of x is another way of saying y. The y value is 19 when x equals 3. One might argue that one method is easier than another to obtain the result, right? Synthetic is definitely easier than long division. That was very apparent on your quiz. Yeah. It's shorter. It's just so easy to get messed up with the minus and the negatives with your long division. I prefer the synthetic. Okay. So, the factor theorem. When a factor is divided into a polynomial, the remainder is 0, and the quotient is called a depressed polynomial. So, factor is the thing you're dividing by, the dividend is the original, and then your answer is the quotient plus remainder 0. Okay. So for instance, if I'm taking 24 and I'm dividing by 3, what is the quotient? 8 plus a remainder of 0, right? Because it's actually a factor. 3 and 8 are factors of 24, right? Factors are things that multiply together to equal the answer. So 3 times 8, 24. Okay, we could try another one. Okay. Let's say I have a function, f of x, and it's x squared plus 6x plus 5. We can factor this. What's the factor going to, what are the factors? What adds to 6 multiplies to 5? Multiplies to 5, adds to 6. 5 and 1, right? So you're doing the opposite one. You're adding to the end and multiplying to the end. Okay, so remember we add to the middle, multiply to the end. So this is just going to be x plus 1 and x plus 5. Okay, so what this means is if I take x squared plus 6x plus 5 and I divide by x plus 1, what should my answer be? What should my answer be? Should we go through and test it? Yeah, let's do it. I did not give myself very much room at all.
You should get
Let me move this over.
the y value.
Okay, so I'm taking x squared plus 6x plus 5, and I'm dividing by x plus 1. Do we know what the answer is going to be? What times x plus 1 is x squared plus 6x plus 5? Yeah, x plus 5, because together these two multiply, and that's what it's equal to. Okay. I'm just trying to show you, like, what this means. So we can go through and divide, right? X squared divided by x is x. Multiply this out. X squared
So
plus
this is
x.
basically like foiling.
More,
Except you're not
no,
foiling
it's
the
not
five.
foiling at
It's
all.
not foiling. You're dividing the original problem by x plus 1.
So I'm proving to you guys right now that, like, oh, guess what? When I divide by one of my factors, I get 0 remainder. So if I'm dividing a polynomial by one of its factors, it should go evenly and I should have no remainder. And I'll have, the answer will be another factor of my polynomial. So it will be called a depressed polynomial. The quotient is a depressed polynomial. Because it's missing, right? If you're depressed, you're missing part of yourself, right? You're all sad, whatever, heartbroken. You're a depressed polynomial, you're missing part of yourself. Right? The dividend, we took out one of the factors and now it's missing that factor.
Well, too bad, because I need to get an A on the next test. So, we need to test for that. You get
True.
a number.
So, I'm going to demonstrate this by the example, okay? So, we're going to use synthetic division to prove, to determine if x minus 3 is a factor. Because if it's a factor and we divide, our remainder should be 0. If something is a factor and you're dividing by it, you shouldn't get a remainder. It should go evenly, right? If I take 24 and divide by 5, it doesn't go evenly. I'll have a remainder. But if I take 24 and divide by 6, it goes evenly and I know it's a factor. So if I'm trying to see if x minus 3 is a factor, that means I should have no remainder. Yeah, so we're good. If it is a factor, if it is, then we have to fully factor it. No worries, right? Let's go step by step. So first, we're just going to use synthetic division. So I have x minus 3. So what number should be on the outside of my little boxy? Positive 3, right? It's the same number, but opposite sign. As long as you don't have a number in front of x. Or you could take the x minus 3, set it equal to 0, and solve for your x to see what number goes there. Okay, now we have to go in order, right? 3, 2, 1. Okay, so they're in order. I'm not missing any exponents. So I have 1, 4, negative 15, and negative 18. You pull the first one all the way down. If it's on the outside, you must multiply. So 1 times 3 is 3. Now, we have it on the inside. Inside, you must add to 7. Outside, multiply. 21. Inside, add 6. Outside, multiply. Inside, add. Woo, okay, 0 remainder. What does this mean? Is x minus 3 a factor of this polynomial? Yes, because it doesn't have a remainder, so it is a factor. Wonderful. So we know it's a factor. Now, it said if it's a factor, find the other factors. So I don't know. This is so hard to do. So what does this 1, 7, and 6 mean? What are they? Rewrite it. Exactly. Oh my gosh, Dylan, you're on it today. With a point. Here we go. Woohoo! Perfect. Okay, so we just have to rewrite it. I started with an x cubed, so we always start with one less. So I have x squared plus 7x plus 6. All right, so this is my depressed polynomial because this is what's left out. Depressed polynomial. Because my function, right, f of x, my original function, this guy right here, it's equal to x minus 3 times the depressed polynomial. Because together, if I multiply these, I'll get back what I started. Okay, but we have to fully factor it. So I have to factor what this purple is, right? X squared plus 7x plus 6. So try to write the fully factored form underneath. So what adds to the middle multiplies to the end. 6 and 1. Cool. So you just write x plus 6, x plus 1. This is our answer because it said determine if it's a factor. Since we have no remainder, we know it's a factor because it goes evenly.
Wait, so for the answer, do we have to write f of x equals x minus 3 also?
We want it to be fully factored.
What?
We want it to be fully factored. We're trying to fully factor the polynomial.
I know, but
So
answer, can we just write x plus 1 times x plus 6?
Okay, it did say find the other factors. That's fine. If it said fully factor, you'd have to write all 3. Do you know what I'm talking about? Since it said find the other factors, and so these are the only other factors.
Yeah.
I'm trying to be clear with like when I write the directions what I want. If I just want the other ones, cool, the ones I didn't have. But if I say fully factor this, if it is fully factor, then you have to write all 3. Coolio. We have one more problem? Beautiful, and then we'll go over some of the practice like I wanted to yesterday. Wonderful. How do we feel about this so far? Is this okay?
Yeah.
All right, solid. This is, yeah, about the level of what I want. Given a polynomial and one its factors, find the remaining factors of the polynomial, then graph the function. Okay, you know what? We're not going to graph, whatever. Don't need to do that. Intermediate, cutting stuff out for you. Okay, so I want you to try this. I want you to try this. All right, so you have a polynomial. You are seeing if x minus 1 is one of its factors. So I want you to try this, right? We just did an example. Go ahead, try it. On your paper. Let's do it. No. Only 5, 6. So. Let's get that to 10 minutes. Okay, so I have the solution up here. So leave it up for a little longer. Let's see. I want you to try number 1 on the next page. So right here, when you're done, I want you to try out this guy, okay? On the next page, I want you to try number 1. Do you have this as your next page? Yeah. So you're using synthetic substitution to find f of -5 and f of 2. So you have to do 2 different synthetic divisions here. Okay, do we need this up longer? No? Okay. So this is why I said synthetic is so important, because like we're using it for synthetic division, and we're testing if things are factors. So like we're not just dividing, we're like doing 2 specific things just with synthetic division. Okay. So I want you guys to try this one. I'll give you like I don't know, 30 seconds or so. Did you need me to go back? No. Okay. If you have 3/4, yeah, so everything is okay. You guys can use your calculators as well. All right, hopefully you've had enough time to start it. So f of -5 I'll do over here. Put the -5 here, -3, 5, and -1. Bring down the -3. -5, -3 is 15. So add these, you get 20. 20 times 5 is -100. And when you add these, you get -101. So f of -5 is -101. Okay. So it's the same numbers, coefficients to set up the next, but I'm using 2 instead. Bring down to the -3, you get -6. Add these together, -1. Multiply, you get -2. Add, you get -1. So f of 2 is -1. So where are we missing things? Is it just the like multiplication of numbers, or is it the method, right? If we're getting the method, yeah, we have to do it twice because there's two different numbers to find for both of these. So if you're done, we'll do number 3. We'll do number 3 now. So if you're done number 1, try number 3, right? So we've done an example of how to do it. I want to see everyone work on number 3. Asha, you done? All right. What answers did you get?
3?
Yeah, number 3.
No, I'm starting 3 now. I finished the other one.
Okay. Why did I put a 0 here? Why do I have a 0? There's no x, right? I have a cube. I have an x to the third, x to the second. There's no x to the first, so I have to put a placeholder. Tricky. Trick. Negative 40. Add negative 40 plus 200. This is 195. That's a big number, but you could use your calculators. That's fine. Can't be scared of big numbers. Oh my gosh, we get the same answer? Wow. Same answer as before. Yep. Sure. Well, Dylan's gone. Wait till he gets back. Unless it's like an emergency, then you can go, but prefer not to have too many peeps walking around. Okay. How do you feel about these? Yeah, okay. So, if you're done, try not to rush. I just want to, practice. We're going to go to the next page, which is the remainder and factor theorems. Okay, so we're going to do numbers 1 and 3. Okay, we're going to do 1 and 3. There's lots of practice today, right? You trying it. Because if you're getting it, like when I'm like, oh, try these problems. If you can do them right now before we go over it together, then you're gonna be solid. You just gotta whip through your homework and you'll be good. Given a polynomial, one of its factors, find the remaining factors of the polynomial. So what's the trick here? What's the first thing we have to do? Okay, that was a really vague question, right? We're doing synthetic division. We're going to add 2. We want to see if it goes evenly. So I put a 2 right here because, you set this equal to 0. To find the number you put right there. Then I must list all of my coefficients. 1, negative 10, and 8. It's just synthetic again and again. And this is why I keep having you guys try it. This is why I keep having you guys do synthetic division. Since it goes evenly, we know it's a factor. X squared plus 3x minus 4. Yep, we got to fully factor that. Let's see. Find the remaining factors. So we just have to find the remaining ones. So I think Ruby was the one saying it before. We just have to find what this depressed polynomial factors into. All right, so what adds to 3, multiplies to negative 4? Do we know? I'll give you another minute or so to try. Exactly, plus 4, minus 1. Wonderful. These are the remaining factors. Amazing. Okay, I'll leave this up here. But I want you to try number 3. It's a little harder. Yeah, so on the actual quiz, when I ask you to do something like this, I only give you a cube function. You just have to divide once and then factor. So, doable. Yeah, ooh, it's fully charged. Yep. So of course, you will have your calculator, So a problem like this, it's totally fine. Like, it's fair game. Because I'm not expecting you to know what 15 times negative 7 is. You know, like, that's something you just type into your calculator. That's fine. But what I do want you to know is, oh, okay, so given a factor, how do I find the rest? You have to do synthetic division, and then the answer you have to factor, right? So I'm expecting you, like, your brain to know the method, and your calculator can, like, do the little computations, whatever. That's why they're invented. Okay, so you have to know the method. You got to apply it. And, of course, when you show your work, it lets me give you as much credit as I can. Because if you don't have anything written, I mean, I have no idea what's in your brain. I am not a psychic. All right, so we see no remainder. We know it goes evenly. So since we start with a cube term, down here the answer will start with a square. Awesome. So I'll leave this one up here. Let's take a quick poll. How do you feel about, like, today's lesson, right? The stuff we've done? Are we good? Yeah? Okay. I know I am going fast right now because I'm just, like, whipping through problems, right? Just want you to try it. Because I want your self-confidence to be like, you know what? You sat here in class, did it on your own before we went over it, and you did it correctly. Like, I want you to know that you can do it because you can. Like, you guys are fine. So that is the, like, we went over 5.6. Then we went over some, like, example problems. Like, what would literally, the 4 I went over are just like the quiz. All I do, change it up a little bit. Like, I give you 2 problems, just like this, where you use synthetic substitution, right? And each one of those problems is like, oh, I have 2 numbers, plug in here, 2 numbers, plug in here, right? You see how I had, like, 2 numbers to find? Okay. Then I give you 2 problems just like this, where you given one of its factors and you fully factor the rest. It's very straightforward. I'm, like, telling you exactly what's on it. There's 14 questions total, and, like, 1's a bonus. So now I want to go back and I want to review 5.3, right? We're going to spend the last 10 minutes going over the 5.3 practice that you got yesterday. I'm just going to pick problems that are similar to the ones that I put on the quiz. If you can do those, like, you are going to be A-okay. It'll be great. You just have to do your homework. Okay, so we're going over the 5.3 extra practice. I gave this to you yesterday. I'll pick some rando problems. Yes. Okay, so you just have to watch the last part of the screencast, Eli. That way you see what we're doing. All right, we're going to do 1. Let's do 2, 3, and 4. All right, let's do these 4. This is the 5.3 practice. It's what I handed out yesterday. Yeah, I wanted to get to it yesterday, but it's fine. It's all coolio. So, these 4 problems, we're trying to state the degree and the leading coefficient of each polynomial in one variable. If it's not in one variable, you have to explain why. Okay, so leading coefficient and degree. So we're just gonna go around the room and go through. Yes, yesterday in class. I handed one out. Yes. Wonderful. Okay, we are going to start with Miranda. All right, so what is the degree? 1. How do you know? Yeah, the degree is always the highest exponent. There's only one variable here, and if the exponent's not written, it's assumed to be 1. Okay, leading coefficient. Elizabeth, what is the leading coefficient here? What? Who said this? You just okay, it's fine. You said 1. It's just the number. It's the coefficient in front of it. Yeah, no worries. Let's do 2. Let's do 3 before we go over to 2. Yeah, let's do number 3 first. I want to come over. Gabby, what is the degree? I'm sorry, Lauren Gabay.
Mm-hmm.
Is that how you say it?
What?
Last name?
It's Dubai.
Goodbye. Oh, like goodbye. Lauren, goodbye. What's the degree here?
5.
5. Perfect, because it's the highest exponent. Then the leading coefficient, Ruby. Oh, okay, -5. Here we go. It's all cool. We feel confident with this stuff? As long as I give it to you, it's confident. Okay, well, let's go to the harder one. Maybe like number 2. Ooh, I think Ruby said we had to FOIL it. Gotta FOIL it.
So, in terms of, is it ax squared or ax cubed?
Yeah, ax cubed
Okay. Plus 6x minus 4x squared.
minus 3. Okay, so it's a little hard because it's not in standard form. It's not in descending order of exponents. But what is the highest exponent, Jesse? 3, right? That's the degree. And then, Jesse, what's the leading coefficient? 8. Okay, cool. Right, we're good. Let's go to number 4, Ashton.
4. 4 is where the LC,
The degree and the leading coefficient. Leading coefficient is?
The leading coefficient is 18. No, 7.
7, and the degree is 6. It's not in standard form. So, tricky trick. You have to look for the highest exponent, wherever the highest exponent is, pick that term, and then the coefficient's leading coefficient, and the degree is the exponent. How's that? Awesome. Okay, these are similar to the first 4 questions of your quiz. They're like quick. So when I say there's 14 questions total for the quiz, I mean that's like 4 right there. Like, chill. And I just told you what another 4 is. Okay, let's do some more. Which one should I do? Let's do this one, 9 and 10. Let's do 9 and 10. Yep, you just plug it in. It's just pure plugging in, direct substitution. So these 2 are similar to 2 of them on the quiz, just direct substitution. But you have to keep in mind you're finding 2 values. 2 values for each of these. So p of -1, 2 times -1 squared minus 4 times -1 plus 1. Okay, so you have to square it first before you can multiply. Order of operations, exponents before multiplication. What? Let's see, 2 plus 4 is 6 plus 1 is 7. Oh my gosh, I wrote really big. Yeah, we're doing 9 and 10, and there's 2 problems for each of these.
Are we going to do 11?
No, or am I doing 9 and 10? But, I mean, I'm like, you can do them for more practice if you want, but I'm just doing some selection to...
What was the other one?
Which other one? We're doing 10. I haven't done the second part of this problem. I just wrote a little too big, and I didn't give myself enough room, so I had to scooty boot. I just scooted over. Okay, now we have to find p of 2. So you just plug in 2 everywhere. Oh, so someone said they got 1. This is where they got 1. I see. P of 2 equals 1. And when there's a problem like this, it's helpful to identify. That way, I mean, there's like 2 problems in one. It'd be helpful to identify which is which. Yeah. All right, number 10. Just straight up plugging in. -1 times -1 times -1 is just -1. Yep, minus 5 plus 3. Yes. You have like 3 minutes left of class. It's your option. Okay. Perfect. All right. I'm gonna freeze this up here. I guess we do have actual 3 minutes. What? You haven't done anything yet? We're doing 17 through 20, and like those are all the ones that's where we'll end for today. 17 through 20, what? What one?
Yes.
So negative 16, and then 10 plus 3 is 13, so negative 16 plus 13. You do, well, you're supposed to multiply first. So you should have negative 16 plus 10 plus 3, and then left to right. Negative 16 plus 10 is negative 6, plus 3 is negative 3. Yeah, okay, actually. Okay, 17 through 20. So this one, we're doing direct substitution, but it's not numbers, it's variables. So P from up above, because it's hard to see, P is equal to, P of x. It's just a function is equal to 4x squared minus 3. So if I'm plugging in a squared everywhere there's an x, P of a squared is going to be 4 times a squared squared minus 3. Ooh, we have a power to a power. What happens? A squared squared turns into a to the 4th minus 3, right? 4a to the 4th minus 3. Tricky trick. Ooh. That's it. Try number 18. Do 18. Oops. So r of x from, up here where it says, I just want to make sure I leave my work so you can see it. R of x is equal to 1 plus 3x. So if I'm saying r of x plus 2, everywhere there's an x, you have to plug in x plus 2. So r of x plus 2 is going to be 1 plus 3 times, I'm plugging the whole thing, x plus 2, in for my variable. So the reason I leave my parentheses is I have to distribute that 3 out. And then to simplify, it's just going to be 3x plus 7. Okay, so, wait, when does this go to? Okay, so we do need to wrap up. I want to talk verbally about these before we stop. So the end behavior for number 19, right? As x goes to infinity, what's happening to my function? As x goes to the right, what's happening to my y? It's going up. And as x goes left to negative infinity, what's happening to my function? It's going down. Yeah. And then we know this is odd because they go in opposite directions. And then there's only 1, 0 because it touches the x-axis at exactly 1 point. And that's in comparison to the other one, which is even, because they go in the same direction. They both are going down forever. It doesn't matter which way I'm going. My function is going down to negative infinity, right? It's going down. If it's going down, it goes to negative infinity. And then the number of real zeros is how many times it crosses the x-axis. So that's 4 zeros. Okay, and that's everything I wanted to cover today. So have fun. Good weekend. See you Tuesday. Martin Luther King Day is Monday.